21 on chapter 6. It says use the work energy theorem to solve each of these problems. You can use Newton's laws to check your answers, neglect air resistance in all cases. So part A says a branch falls from the top of a 95-meter tall redwood tree. Starting from rest, how fast is it moving when it reaches the ground? So part A. The theorem that it talks about is work equals so we'll just plug in our values. Now it doesn't give us a mass, so I just ignored mass, just like assumed it was 1 or something, and it totally worked. So I don't know if there's a more better way to do that, but so I just kind of ignored mass as far as gravity goes, and just did the acceleration of gravity, 9.181 as my force times cosine theta. Now they're in the same direction. Gravity's going to be pulling down, and because if you think about it, I'll draw a picture. If it's a tree, and here's its branch, and this height is 9.5 or whatever. Gravity is going to be, this is our branch, pulling down on the branch. As the branch is moving, its displacement is also down, so that angle is 0. So that's just going to be 1. Cosine of 0 is 1. And then the displacement is the height of the tree, which was 95 meters. So you plug that in your calculator and work equals 931.95. Now the theorem is that the total work on something equals the change in K, and K equals 1/2 mv squared. So we can set this total work, 931.95, equal to 1/2 the mass, which again I'm just assuming is 1 because they don't give it to us. 1/2 times the mass times velocity squared. So then we're just going to solve for velocity. So v is going to equal the square root, so we have to square that, of 2 times 931.95. And that is going to nicely equal 43.2. And then B, I'll just erase this guy and do it over here. Hopefully if it's too glary or whatever, I can fix it. So part B says a volcano ejects a boulder directly upward 525 meters into the air. How fast was the boulder moving as it left the volcano? So for this one, we're going to have to use potential energy and kinetic energy. So we know that work equals negative delta U, which this delta U is potential energy. So that's the same as saying negative mgh equals 1/2 mass times velocity squared. So when we look at this, the mass will cancel out, and we're left with negative gh equals negative 1/2 v squared. So v equals the square root of 2 gh. So when we plug those values in, v equals the square root of 2, gravity 9.81, because again we're not given the minutes. And then the height, which it gave us right at the beginning, was the 525 meters.